Alright, this time I'm working with the IOLAb, and right now I have the IOLAb hooked to D5, which is a PWM or pulse width modulated output, which puts out a square wave. That's in line or in series with a 220 ohm resistor, an LED, and then it's connected to ground. And right now on the screen it looks like it's flashing much slower, but it's actually flashing at 20 hertz. You can visually see that it's faster. The problem is the refresh rate of the webcam isn't that great, so you can't see it flashing at the normal speed. Now let's move over really quick and change the value. I'm going to just change it to a different frequency, and now it looks like it's solid, but you can still visually see it's changing. So let me change it back. Alright, now let's move over to the screen and see what it looks like, or how to program this thing. Okay. Alright, so this is the GUI that opens up when you first start IOLAb. If you notice, I got my dongle connected. I also got my remote connected, and that's how much battery voltage is left in the two AA or AAA batteries. For this test on measuring or changing the output, I'm going to be using the light sensor in just a minute. So I'll turn that on, and also I need to turn on these advanced options under the little gear, output config, and remote 1, because that's the one I have hooked up. This is what it looks like. Now it naturally has this thing in here that you can turn on D6 or D6, which is digital output 6, to turn on and off just straight voltage 3.3, but let's not use that one right now. Let's use the expert options. And so key number 19, or number 19, is the D5, which is a PWM output. Now if I click on 0, that's setting the output. Now if I click change it to 0 and set it, that turns it off. If I turn it to number 1, that turns it on as a digital reader. Now if I turn it to number 2, it sets it as a PWM output, which is a digital signal, which you can change the frequency. So now change the key to number 1 and set the value to 0. This will record, this will be 20 hertz, just like we saw just a moment ago. And let's go ahead and turn off the lights and take a quick reading and show you. So I have the lights off now, and I have the light sensor directly next to it. Let's go ahead and hit the set output. Now record. Notice it's really teeny down there. I'm just going to go ahead and hit stop, just a couple seconds. Now a neat little trick is if you click on the magnifying glass and actually click on the data, it'll auto scale your axis for you. And if you notice, it's not perfect. It has some fluctuations due to the noise of the system, and also it's not a perfect LED. So next I'm going to do an FFT at 512, and I choose a region. And if you notice, it's a little hard to see, and my data samples, 512 data samples, isn't that big, so I'm going to change it to 4096, and it collects a lot more data samples. Now if I click on the gray box, I can move it, and I click again. Now I can just move and measure something else, but let's just go ahead and take a sample from here. Now you have to drag it straight down and click over here, and 19.4 for 19.8 hertz. And if I go up to here, 59.5 hertz, and if you looked really close, you could see a little null at 40. Alright, so that's how you take a quick sample. Let's go ahead and change the value to 2, and that should set it to 30 hertz. Click restart, record, stop, zoom in on the data. There we go. Do an FFT at 4096, select a region, move the cursor down, and there we go, 30 hertz. Alright, so the key number 1 is low frequencies, and it starts out at every 5 hertz, and you can go from 0 to 31 and goes up to like 1200 hertz. If I change it to 2, key 2, once again you can go from 0 to 35, and I think it goes up to from like 1200 hertz to at 31 it goes to high frequency like 11,500 hertz. And then key number 3, 0 to 31, starts out at 12,000 hertz and goes up to like 31 or 32,000 hertz. You'd need an O-scope to really record these higher frequencies above, let's say, 40 or 50 hertz. The reason is because as soon as that LED is flashing on and off really fast, it can't record it through the light sensor anymore. It just becomes a big blur. And anyways, so don't go too high if you're using an LED to measure this. All right, so that's how you set the output. Let's go ahead and turn it off. So set that to 0, set that to 0, hit set output, and that turns it off. One last note on this: if you were to turn it back on, you can see why resolution or refresh rate of light bulbs and TV screens and computer monitors have to be so high, because in the lower frequencies you can actually see it blinking, and then in the higher frequencies you can't see it blinking. So that's one last application. All right, thanks for watching.